I'm going to continue with the magnesium dissolving in gold nitrate, gold 3 nitrate problem. And this continuation is using the reaction stoichiometry to calculate the mass of gold that we expect to precipitate. In the first video, we wrote half reactions for the balanced redox reaction. Now we're going to use the reaction stoichiometry and a periodic table in order to calculate how much gold we expect to precipitate when all 0.156 grams of the magnesium wire have dissolved. The way that we're going to do this is the same strategy that we've used in previous conversions. We're going to start with the grams of magnesium and we're going to convert that to moles. When we have the moles of magnesium, we'll use the mole ratio between the magnesium and the gold in order to convert to moles of gold. And then finally, we'll use the atomic mass of gold in order to find the expected grams of the product. So we always want to start with what we have, and what we have is a piece of wire that's 0.156 grams of magnesium. The first conversion that we're going to do is to convert into moles of magnesium. So we're going to put what we want on the top, and that's moles of magnesium, and what we have on the bottom is grams of magnesium. Now, if we look at the periodic table, we'll see that 1 mole of magnesium weighs 24.31 grams. The mathematics say that the grams of magnesium cancel, and now we are in moles of magnesium. We then can convert from moles of magnesium into moles of gold. Remember, we have to be in moles if we want to compare an amount of product, an amount of reactant to an amount of product. So what we want is we want moles of gold, and what we have is moles of magnesium. From the reaction stoichiometry, we see that there are 2 moles of gold for every 3 moles of magnesium. That's 2 moles of gold for every 3 moles of magnesium. The moles of magnesium cancel out, and then we can do our conversion to figure out how many grams this many moles of gold represents. So what we're trying to find is grams of gold, and what we have is moles of gold. We go back to our periodic table and we find what 1 mole of gold weighs. A mole of gold weighs 196.97 grams for 1 mole. The moles of gold cancel, and now we can simply plug these numbers into our calculator. 0.156 grams, 0.156 times 2 times 196.97. That result gets divided by 24.31, and it also gets divided by 3. The result should turn out to be 0.843 grams of gold. So, we've taken a problem that involved a redox reaction when magnesium wire dissolves in gold 3 nitrate. Gold metal precipitated, and we wrote a balanced redox reaction. In the previous video, I showed the writing of the half reactions for both the oxidation of magnesium and the reduction of the gold 3 ions. And now you've seen that we can also use this type of problem as a stoichiometry problem. So we've calculated the expected amount of gold that we would recover.